In this part, so we are going to see how we can change ABC form. That means y is ax squared plus bx plus c changes to y is a bracket x minus h squared and then plus k. So the method, we have a name, so it's called method of coming square, which is a very commonly asked question, commonly asked method in HKDSE. So the way to do so seems very terrible because it's called is adding the term of k over 2 bracket square. So what does that mean actually? Indeed, so it's something that you've got in Form 2 quite a long time ago in identities. We have got two identities. It's called a plus b bracket square. So it's a square plus 2ab plus b square. So if it is in negative sign, it's called a minus b squared. It's a squared minus 2ab plus b squared. Let's see what's actually k over 2 bracket square means in making us perfect square. For example, like if you have a function like x squared minus xx. So in order to make a bracket square, because it is required in the vertex form, you need to add something in order to make it a perfect square. That is the b square term. So in order to do so, you need to fit minus xx and minus 2ab in your function so that you can write it as a completing square. Now a square is x squared. Minus x will be written as 2 times something times x. Can you identify the number in the brackets? Yes, because you have taken out a already, which you have taken out 2 already, so that's why the number should be 4. So you can see it's now in the format of 2ab. A is x, 2 here, and that's why it's a 4 for the value of b. In order to make it a perfect square, you write it as minus 2 times 4 times x and then plus 4 square. But you can't just add 4 square because it's nothing originally in the question. So that's why you need to minus 4 square in the function. So after that, in this green expression, it turns to x minus 4 square according to identity, and you still have a minus 16 in the function. So that's the way how you can write it as AHK form, a vertex form of a quadratic function. If you find perfect square is very hard to do so, you can go back to the previous page. Now it is page 8 here, so you can go back to page 7 to have some practices over there first. Now we pick part B as example in this video, and you can try the other questions later on. So let's take a look at part B. So it is y is x squared plus 6x plus 7. If you are very good in identity, then you'll try to have a fill in the blanks first. So what should be the number here in order to make a perfect square? So in your thinking, it's like you have x squared plus 2 times x times 3. So that's why you need 3 square in order to make a perfect square. So that is 9 here. We have add 9. But we can't just add 9 quite suddenly in the function. So that's why you have the minus 9 at last. In the first 3 expression, it becomes identity. So it is x plus 3 squared. While the latter 2 terms, it goes to minus 2. That completes the question about completing square. When you read the question, another point I would like to highlight is when you read the question, it requires you to write as minus h squared and plus k. But in my answer, I write it as plus 3 and minus 2. It doesn't matter because the main purpose of writing in this way is I want you to change the question from ABC form into HK form. So the symbol itself is plus or minus here. It's not really a matter. So that's why don't be panic about it. Next, we have we try to take a look in part E, which is quite terrible because the A is not just a 1, but it's a 2. We don't, the little trick, little technique is we don't include it in the coming square, which means, first of all, we have to take out 2 as the common factor first. So that's why we have 2x squared, 2 brackets x squared minus 4x and plus 13 over 2. So it's a bit terrible because you've got a function in the constant term. It doesn't matter. So we still keep the 2 over there, x squared minus 4x, and now fill in the blanks. Can you find out the number in order to make it a completing square? So the thinking skill is x squared minus 2 times x times 2 in order to get minus 4x. So because it's 2 here, so you need a 2 square in order to make a completing square, which means it's a 4. So after adding a 4, you have to delete it, so which is called minus 4 here. As a result, in the expression, the first 3 becomes bracket square, which is 2 times x minus 2 all square, while the latter 2 will be put in together, which is plus, what is it, 5 over 2. After that, you have to expand it. We've got 2 times bracket x minus 2 square, while 2 times the latter term, you've got plus 5, and it completes the question. A similar situation will appear in part D when you have a minus sign here. So you may try to have a look or have a try in part D in your own work. Next, we jump to example 10 to see integrated question of vertex form or other format anyway. Now let's do the question together. You've got a quadratic function, so it's not in vertex form or standard form, so you can see the vertex, you can see ABC directly. It's factorized, as well as you don't know whether it's a happy graph and happy graph because n is unknown. But anyway, if it's happy graph and happy graph, so you will see x is a minus 1 and x is 2 in the diagram. So that's why somehow you will know, we know the intercepts, x-intercepts of the parabola. So it should be minus 1 or, no, minus 1 and 2. 2. Okay, and a 2 here. And then so we try to see whether we've got some more information about it. And because there's an unknown n, you've got a point, so that's why it implies you need to do substitution as well. Once I start reading a question, I find my guess or my study is correct because it's really asking me about x-intercepts. That's why, according to my study, then part A, you need not to do anything and nothing to be done. And you can write, not really nothing, but we will say or write the steps in this way. Because of finding x-intercept is talking about putting y is 0. You put y is 0, and you are solving n times x plus 1, x minus 2 equals 0. N can be cancelled, so that's why we've got 2 brackets, the product is 0, which gives you x is minus 1 or 2. So that's why the x-intercepts, they are minus 1 and 2 respectively. If the question is just 1 mark in, say, an exam paper, so you're most welcome to just write down the answer directly. Coming up next, we go to part B, that we are going to find the value of n. Do you remember a sentence I just mentioned a minute ago? That's nice. If you want to find a noun in a diagram, you should do substitution. So that's why you put 1x into the function called y is n, x plus 1, x minus 2. So which gives you, what's that? X is n, 1 plus 1 is a 2, 1 minus 2 is a minus 1. So which gives you minus 4 finally. So that's why we can delete the first diagram, so which is wrong. I should be the proper picture about this quadratic function that we're studying. Coming up next, it is something we mentioned in the last video about optimum value. So which means it's talking about, do you remember it? Nice. Optimum value, you're talking about maximum or minimum. And after we know n is -4, you know it's an unhappy graph, which means we are going to read the maximum value of the parabola. Secondly is when you see this word optimum value, so it implies a very big hint to you, which is you need to rewrite your question about the quadratic function in the form of AHK form, into vertex form, or else you can't see the vertex very clearly. Oh, then that comes to a very big task to us, right? Anyway, we try to do it one by one. Let's move the paper here. Okay, firstly, part C. Now the the quadratic function should be written as -4, x plus 1, x minus 2. It's not in ABC form, so that's why I need to expand it first, right? So that's why y is -4, x squared, so I write faster, minus 2x and plus x is minus x, minus 2, and you've got, okay, let's hold up. I need to expand it once again because in HK form, the A should be outside, right? So that's why I will keep this one here, -4 here, and then now I start studying. Oh, what's the number I should put here in order to make a complete square? It's a little bit harder because it's not an even number, right? It's not like the example I just mentioned a page before. So that's why somehow, if you remember, this number is given by the previous number 1 over 2 bracket square, so it helps you to do the question a bit faster. It's plus 1 over 4 and minus 1 over 4 respectively. So the first three terms, it gives you complete square, which is x minus half bracket square. While the latter two numbers, combine them, you've got minus 9 over 2. And then next, -4 expanded, you've got minus 4 brackets x minus half square, and then plus, after cancellation, you have plus 18. So it is the another format or vertex form of the quadratic function. If you still remember, the vertex means the value of k. Now you've got, what have you got? Okay, the vertex is half and 18. Okay, vertex here, half and 18. Do you remember that the value of k here, which is 18, telling you about the maximum highest point of the parabola? So that's why if you can remember this idea, part C you can just write directly now. So we say not just optimum value, but we say maximum value. The maximum value now is 18 in the question. That's all. Do you understand how we can do it? If you can understand the question quite well now, that's brilliant. It's really not a very easy question to understand. So it's very good if you can understand everything very well immediately. So before we end the task today here in this video, so I would like to share with you another little trick of the question, which is, so besides writing the quadratic function in the vertex form, sometimes if we have roots minus 1 and 2 here, we have a little trick to find hk in another way, which is, you remember that quadratic graph parabola should be symmetric, right? So that's why this point, it should be the midpoint of minus 1 and 2. And that's the little trick, not really little, but it's a very big trick which help us to find h in another way, which is, so we say not really midpoint, we can just directly say h is equal to, repeat, midpoint of minus 1 and 2. Midpoint is like average, so that's why we add the numbers together. The roots are minus 1 and 2, so that's why it helps us to give you 1 over 2 directly. Now how about k? How can we find the k? It's unknown, right? So if we want to find unknown in the diagram, what shall we do? Yes, it's about substitution. H is 1 over 2 now, k is unknown, so we just write 1 over 2 and k. Into what? It's a point on the diagram, so that's why it's minus 4 x plus 1 and x minus 2. It's a very simple way now. But the only point you have to, or how you can use this way, is you have to understand or remember that for a while that as of symmetry appears in a parabola, that means the parabola is symmetric. If it's a question about roots, then midpoint is a very, very big trick in order to solve the problem. Now let's go to solve the problem and see whether we really can get the same answer. And okay, so after substitution, y is a k, minus 4 is still here, 1 over 2 plus 1 is 3 over 2, right? 1 over 2 minus half is minus 3 over 2. So by using calculator, oops, I've got k is 9 here, so there should be a mistake I made in either one part. So let's help to verify it together. Okay, I find my mistake, sorry. And the mistake comes from, okay, it's not now over 2 here, but it should be 4, sorry about it. So that's why the value of k should be a 9, maximum value it should be a 9 as well. And so don't forget to amend the answer in the diagram. It should be a 9 here. Okay, I'll rewrite it, 1 over 2 and 9 for the vertex. So that's why the maximum value is a 9. And then, okay, so this one is correct. This one is correct. By the way, the maximum value of the function is 9, or that means the value of k. Thank you for helping me to amend it.